In this video, we will talk about gut microbiota and in particular about how we can intervene to modify it. Surely, many of you wonder what type of microbiota you have and why you have certain microbiota. Is it a lottery? Well, it's not a lottery, but it depends on many factors, and some of them we cannot control. So, somehow we have the microbiota that we got. Although, as we will see in this video, we can intervene to a certain extent and modify it. When we are in our mother's womb, it is considered that almost 100% of our cells are human and there are no bacteria in our organism. We can consider that we are practically in a sterile environment, that is, without microorganisms. Shortly after birth, however, 90% of the cells in our body are bacteria and only 10% are human cells, which means that we acquired bacteria during our birth. And the type of delivery determines the type and origin of the bacteria that we acquire. If we are born vaginally, bacteria are acquired by passing through the maternal vagina, which contains bacteria that are optimal for creating healthy microbiota in the newborn. This is one of the advantages of vaginal delivery over cesarean section delivery. In fact, it has been observed that in pregnant women, when the time of delivery approaches, the microbiota of the vagina change and the amount of some bacterial species increases, such as some lactobacilli, which will be very useful for the baby during lactation to digest maternal milk. In the event that we are born by cesarean section, the origin of the bacteria in our microbiota will be totally different since we will not pass through the maternal vagina and the birth will take place in sterile conditions. In this case, the acquisition of the bacteria occurs once we are born, and we will obtain them from our mother, but from her skin or mouth, from hospital staff, from hospital facilities, or, for example, from visitors. The microbiota that we acquired at birth. It is defined during our first 4 years of life and influenced by factors such as the type of milk we consume in our first months of life, maternal or formula, food during our first years of life, the infections we suffer, and the medicines we take to fight them, and also genetic factors. Later, from childhood and throughout our lives, there are 2 other factors that also influence our microbiota, and these are our gender, that is, if we are man or woman, and our state of mind. Some of these factors, such as our gender or our genetics, we cannot control, and we have little control over others, such as lactation or infections and their treatment. The most controllable factors are diet and our mood. However, it is important to point out that, while it is possible to modulate the intestinal microbiota in the first years of life, it is much more difficult after childhood. It is important to take this into account and therefore moderate expectations. Now, we are going to see how diet can influence our intestinal microbiota. Let's imagine that we follow a healthy diet rich in vegetables, fruit, oily fish, and fermented products such as yogurt. Such a diet will be rich in vitamins, antioxidants, fiber, and probiotics, and will be low in salt and saturated fat. The bacteria of the intestinal microbiota will be able to benefit from the vitamins and antioxidants that will keep them healthy. At the same time, the fiber, which is their main food, and the probiotics, which consist of living bacteria, will ensure their diversity. Healthy and diverse microbiota ensure the integrity of the intestinal barrier and also produce a large amount of vitamins and short-chain fatty acids that are anti-inflammatory. In addition, vitamins and fatty acids can pass into the blood and access the brain, and since most are capable of crossing the blood-brain barrier, they may also have an anti-inflammatory and neuroprotective role at the level of the central nervous system. In contrast, an unhealthy diet with processed food, pastries, sweets, and few fruit and vegetables will be low in vitamins, antioxidants, fiber, and probiotics, and very high in salt and saturated fat. Such a diet will alter the intestinal microbiota, making it less healthy and reducing their diversity. Altered microbiota can damage the intestinal barrier and produce fewer vitamins and short-chain fatty acids, thus inducing inflammation. The reduction in the production of vitamins and fatty acids also reduces their positive effect on the central nervous system. To better understand how an unhealthy diet can influence the intestinal microbiota, we are going to see in detail one of these nutrients, fiber, which is among the nutrients with the most marked effects on the intestinal microbiota, since it is the main food of the bacteria. In the large intestine, we have the epithelial cells of the intestine, a layer of mucus, and living in this mucus, bacteria that only feed on fiber in green. Bacteria that, in addition to fiber, can feed on the oligosaccharides that form intestinal mucus in orange, and some pathogenic bacteria in purple. If we have a diet rich in fiber for a long period of time, all bacteria will have food, and therefore all will grow and reproduce without problems. So diversity will be maintained over time. If, on the other hand, we have a diet that is very low in fiber for a long period of time, the changes in the microbiota will be very important. If there is no fiber, the bacteria that can only feed on fiber will die, while the bacteria that can also feed on intestinal mucus will survive and reproduce, occupying the space left by those that can only feed on fiber. At the same time, they reduce the thickness of the intestinal mucus, which can facilitate some pathogenic bacteria to gain access to the intestinal epithelium, and they damage it, therefore altering the integrity of the intestinal barrier. The lack of fiber in the diet can therefore induce dysbiosis, that is, alteration in the composition of the microbiota, alteration of the intestinal barrier, and inflammation, and also infections. Therefore, an unhealthy diet can have a very adverse effect on the intestinal microbiota and our health. At this point, many of you are probably wondering how we can reverse this situation and recover a healthy and diverse microbiota. To reverse the situation, obviously the first step is to follow a healthy diet, but there are also some strategies that can help us, such as biotics and fecal transplantation. There are different types of biotics: the prebiotics, probiotics, and paraprobiotics, the symbiotics, and the postbiotics. Prebiotics are the indigestible components of food that the intestinal microbiota uses to feed itself. The most important prebiotic is fiber. Fiber sources are fiber-rich foods such as fruit, vegetables, grains, and legumes, and the supplements. Probiotics are living organisms that can adhere to the intestinal mucosa and repopulate the intestinal microbiota. Sources of probiotics are foods that contain live bacteria, that is, fermented foods such as yogurt, cheese made from raw milk, sauerkraut, olives and pickles, or kombucha, which is a fermented tea from Manchuria, and also the supplements. Paraprobiotics are inactivated, non-living organisms that confer a health benefit to the consumer. The sources of paraprobiotics are supplements. Paraprobiotics are obtained from probiotics through different inactivation mechanisms such as high-pressure treatment, ionizing radiation, ultrasound, or heat treatment. Treatments that break the membranes, destroy or break up proteins, reduce the pH of the cell interior, inactivate enzymes, or damage DNA. Symbiotics are synergistic combinations of prebiotics and probiotics that confer a benefit to the health of the consumer. That is, they consist of simultaneously ingesting probiotics and prebiotics that serve as food. And finally, there are postbiotics, which are substances, metabolites, produced by probiotics, that is, by microbiota bacteria, and which confer a benefit to the consumer's health. Postbiotics can be different types of substances, such as proteins, peptides, and amino acids, short-chain fatty acids, galactose-rich polysaccharides, vitamins, or cell wall components. The sources of postbiotics are supplements. Fecal transplantation is another strategy to modify the intestinal microbiota and consists of transplanting the intestinal microbiota from healthy donors that are considered to have an optimal composition. To do this, feces from healthy donors are diluted and mixed, homogenized, filtered, and the product of this filtration, which contains the intestinal microbiota-derived bacteria, is administered endoscopically or orally. The advantage of this strategy is that a very high diversity of bacteria is administered and at the frequencies or amounts that are found in healthy people. However, in the mixture of bacteria that is administered, there are also pathogenic bacteria, which in people with a deficient immune system can induce infection or even death. The risk that fecal transplantation currently entails and the scarce scientific evidence of its efficacy in multiple sclerosis does not justify its use in people affected by this disease.